Given a circle wherein chords BD and AC intersected at point E. So this given is under the power theorem, particularly segments formed by chords. The theorem states that if two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So this means that whatever the measure of segment BE times the measure of segment DE, that is equal to the measure or to the product of segment AE and segment CE. So let us apply this concept in our given number 1. Find the length of segment BE, wherein AE is 6, segment CE is 4, and DE is 8. So let us use X to represent the missing value of segment BE. So this will be our working equation taken from the theorem. Substitute B is X, D is 8 from our given, AE is 6, and CE is 4. We will then simplify them. X times 8 is 8x, 6 times 4 is 24. Then isolate x by dividing each side of the equation by 8. 8 divided by 8 is 1. We are left here with x. 24 divided by 8 is 3. And that's the measure of segment BE. In our given number 2, solve for x, wherein VW is 8, VU is 3x, and YV is 6. What is the value of this variable x? So using the same, this will be our working equation since it's the same concept. Substitute ZV is, which is x, UV is 3x, YV is 6, and WV is 8 from our given. Then simplify. X times 3x is 3x squared, 6 times 8 is 48. Then to isolate x, let's start by dividing each side of the equation by 3. And 3 divided by 3 is 1. 1 times x squared is x squared. 48 divided by 3 is 16. Lastly, find the root of x squared and 16. So square root of x squared is x. Square root of 16, its principal root is 4. And that's the value of our x.